Okay, once again, good evening to everyone. Welcome all to the next session of the day. Thank you so much, sir, for accepting our invitation. We are really honored to introduce Dr. Amar Patnaik. We are really honored to introduce Dr. Amar Patnaik, Associate Professor in the Department of Mechanical Engineering at Malavya National Institute of Technology, MNIT, Jaipur. With an illustrious career spanning 24 years, Dr. Patnaik has made remarkable contribution to research, teaching, and innovation in mechanical engineering and aligned disciplines. Dr. Patnaik holds a PhD in mechanical engineering from MNIT Rourkela in 2009, along with an MTech in production engineering in 2005, an MBA in marketing 2003, and a BTech in mechanical engineering in 2000. His interdisciplinary expertise and extensive research has made a profound impact in areas such as composite material, tribology, and metal casting. A prolific researcher, Dr. Patnaik has authored 249 journal publications and 102 conference papers, demonstrating his unwavering commitment to academic excellence. He has successfully led 22 research projects, receiving funding from prestigious government agencies such as the Ministry of Textile, TST India, CSIR, SPARC, Ministry of Steel, DRDO, ISRO, and many more. His research impact is evident in his H index of 46 and I-10 index of 183, with over 8,000 citations on Google Scholar, reflecting his dedication to advancing mechanical engineering knowledge. His mentorship has been invaluable, having supervised 38 PhD scholars, 35 MTech students, and numerous BTech students, with 10 PhD students currently under his guidance. Beyond academia, Dr. Patnaik has served as a guest editor for multiple reputed SCI and Scopus Index journals, collaborating with leading publishers like Elsevier, Springer, Taylor & Francis, and many more. His work has received widespread recognition, earning him 9 prestigious awards, including the Ganesh Mishra Memorial Award from the Institute of Engineers, Odisha, from 3 consecutive years, 2009, 2010, and 2011, and the Excellence Paper Award from the Hong Kong Institute of Textile and Apparel in 2010. One of his most notable achievements is being listed among the world's top 2% scientists, as recognized by Stanford University and Elsevier publication in 2011 and 2021 and 2022. Further, his dedication to education was acknowledged when MNIT Jaipur honored him with the Outstanding Teacher Award on September 5, 2022. Dr. Patnaik's contribution to composite material, tribology, and mechanical engineering research continue to inspire students, researchers, and professionals worldwide. His work has set new benchmarks in innovation, product development, and material science. It's truly an honor to have him here with us today. Without further delay, please join me in welcoming Dr. Amar Patnaik. So welcome to the station, sir.
Is now visible? Is it visible?
Yes.
And audible also from my side?
Yes, sir. It's audible and visible, sir. You can proceed.
Okay, thank you, madam. And it's a great pleasure for me to say something about my state. So we are here. This MNIT system lasts 18 to 19 years only. So today what I am going to discuss about the sustainable materials. We have developed multiple materials for different applications, and we'll see one by one to all these things whatever we have developed. And specifically our discussions today is on defense applications only. And there are multiple projects we handled in defense, and presently we are handling. So presently, these are the different area of research what you did and we are doing. And most of our work is the development of materials only. It may be defense application, it may be wind, or it may be hydro turbines, or it may be dental applications, or hip prosthetic applications, or it may be the ISRO for space blade applications. So almost all the cases, whatever you say that these are the development of a new materials. Mainly our work is the development of a materials only. So there are few relevant projects, and we'll discuss not for all. And just I will go through it. That one of the, we can say that for Ministry of Steel, that is one of the dream project for them. It's a development of iron particles, specifically nano irons, from the low grade coals only. What we have developed. At the end, we'll discuss, and this is again another project that is DST specifically for applications of spark and combination of governed by Ministry of Education. It is a Spark International project, and here it is again we have developed some new steel material. It's a steel already is there in the wall, but it is a slightly new steel material, and it is more harder, and it's a specifically developed for shock absorbing applications only. These are. And then another application, this is for ISRO, that is a same what you can say that for thermal measurement of conductivity, specifically thermal conductivity for small samples. It's a a sub-micron level, you can say that. It's a very tough. We are developing that equipment in our laboratory only so that it can measure the thermal conductivity, and this is the ongoing projects only. And this is again another Spark project. This is again international project in collaboration with one of the renowned university in Korea. That is again a development of a high entropy alloy. It is more harder than, you can say that as even diamond also. It is a high entropy alloy. And this is the another project, just an overview of that. This is a project what we have developed for hydro turbines, wind blades only. And here the blade application at present in Rajasthan, there are huge number of blades are there. So it's a damage is again another measure mechanism that how damage is taking place because of the sand as well as some other applications only. So here what we have developed, that the material what we have developed, and it is a totally new material, you can say that. Initially we have started with some only virgin type of materials only, and this project is in a bi-directional weaving pattern, and we have developed this material for specifically for wind blade applications only. And here the mechanism is that the weaving pattern only, because as it is a fiber in general we are using, almost all these companies, those who are working on wind energy, they are working on glass fiber or specifically carbon or some aramide fibers also. Few of them they are working on the natural fibers also, but this is a combination of two different fibers, that is glass as well as carbon only. So there are different steps how we have developed, because everything developed by experimental, it is a tough, so it is better to go with some simulation works and develop through simulation and optimize the methods whole total. And after that we can go with the development of the things in experimentally, so that we can prove it. So here the major concern is that the blade damage, the life of a blade, it is important that most of the times, specifically in a desert applications where the sand flow is maximum, and the climate is also extreme, that is high hot and high cold, both the temperature goes up to 55 degrees centigrade. So it's a high temperature and even low temperature also. So this nature, this high and low nature, that in general, it fails the materials. That is the failure analysis of the materials only. It fails in terms of thermal, it fails in terms of mechanical, it fails in terms of a surface, that is erosion only. So these are the things what we are doing at it at similar type also. We did it. So this is the model what we have developed, that those who are means aspire to work in this area or planning to apply projects to some different funding agencies. So they should try to concentrate these things only, that what exactly is going on at present and what new things we need to incorporate so that it can be achievable projects only. So we started with a model only, that is a erosion model. Generally, you can say it's a erosion in simple terms. We can say it is a surface loss only, surface, because the surface is eroded. It's just like a sand blasting technique only. So the surface is damaging. So once the surface is damaged, then the automatically the other properties is slightly means we can say that the failure will starts from there only once it will damage the surface. So once the surface will damage, then the exact energy whatever is required to get, that also will not get it. So that's why it is the biggest problem, that how we can save the life of that blade more than the desired period. Okay, in general, we can say that in Rajasthan, the life of blades is almost, we can say that maximum 1 year, or not more than that only. So we have to enhance that years also, at least 1.5 years, so that the maximum to maximum cost we can save it. So this is the model what we have developed, that through that it is generally as a kinetic energy model only, because it is the impact of a particle on the surface of this. So through this model, we have simulated the things only, and automatically we can find out that what is the damage properties are there, because the damage will take place. One of the factor is the size of the particles only, because which particle strikes the surface of that is one of the factor only, and the speed of the particles. Simultaneously, the external environment, it may be humid condition, or it may be dry conditions, or it may be in wet conditions like in a rainy seasons. So these are all properties of a damage only, and as well as the nature of materials. What material what we have developed, that is the behavior of the material, the materials, the transformation of the materials, what it is. That is very important to know, that what is the exact transformation, maybe from transfer from brittle to ductile, or ductile to brittle, or it is some semi-brittle to semi-ductile, like this nature. So this transformation is very important to know about, specifically materials, those who are working on energy applications, specifically on wind energy. So here the consumption the technology is that we need to find out the how much it can balance in terms of the velocity as well as the particles. So in general, whenever we will go for a model in simulation, it will comes one particle at a time. But in reality, it's not like. In reality, maybe thousands particles comes at a time, or maybe 10, 20, 100 like this only. There is no limitation is there, and we can't do it. Is also difficult to measure also, or difficult to understand also how much particles are coming at a time. So in simulation, we can say that we can strike at least one at a time only. So through this, we can see that how the particles are striking. Means it is an obvious parameter that the spherical particle, in general, we can consider it is a particle is a spherical, that is a sand particles. Generally, you can say it is a. So it strikes the surface continuously. Once it will strike the continuously, the surface damage will take place. So this is the one of the failure mechanisms. There are other factors. Those who are working on tribology, they can say it is a damage. Those who are working on mechanical, they can say it's a failure of the materials. Or those who are working on a temperature, they can say that it is a grain effects of that materials on. So it is in terms of a the thought process is different only, but outcome is that finally the loss of a materials only. So this is the model that through simulation we can predict that how the materials fails once the sand particle strikes the surface of these composites only. So the behavior, we'll see that through this graph, we can see that how the behavior is, means how the loss pattern is. It is a loss pattern only, but in a different angle. So from this, by these specific applications for the specific materials, it a loss pattern, we can say that at 60 degree, the loss is maximum only. So once you will know these things experimentally as well as in a simulation, we studied both experimental and simulations, and the graph pattern is exactly same only. So through that we can say that at particular degree or particular angle, the losses is maximum. What to do? So if that angle is maximum, that we need to avoid that particular angle. Because at present the design of wind blades are not like the steady type of you can say 10 years back only. At present automatically you can adjust the head of the wind only. So we need to, by this application or by these results, we can say that the particular angle we should avoid it, so that the damage we can reduce, because loss is a not unavoidable parameter. We can't say that it is a 100% means zero loss, but we can reduce that loss only. So that it is important to know which angle has the maximum losses only. That is the important through this only. So similarly, you can say that the erosion pattern of that particular, specifically the sand erosion applications. This is the one of the applications through can say that how the pattern is, graph pattern means at which angle has maximum and which angle has minimum, and where the loss is maximum. That things we need to understand that things. So accordingly, you can develop the material. See that these are things only. Different sand particles, how it strikes the surfaces, damages is taking places. And once you know in a different velocity and different angle for different property of fibers, different percentage of fibers, then automatically at the end, once you will optimize the things, then we can go for development of materials in experimentally. Like this is one of the experimental results. So, and simultaneously simulated results also. So the same thing at particular angle, let it angle is 30 degree or at 45 or 60 or 75 at 90 degree, different angles. So here we observe that this particular fiber, it may be any fiber, but this particular fiber is a synthetic fiber only. This fiber at 75 angle, the loss is maximum. So these things we can study through. Those who are good in material science, they can study these things through scanning electron microscope also. And the same thing we can observe also observe with the help of a NC simulations also. Because it is not possible all means each and every time the facility is there or not. We can do the same things in some other methods, that is through simulations only. We can say that. So this is a valid, we can means pattern that which angle has maximum loss and what particular velocity during that, so that we can avoid that particular things only. These are the we can say that this is a totally new to the system in case of a wind applications only, that this most of the time we are going with a scanning electron microscope only. There we can know the surface property of the materials, how the loss is, whether it is a cavitation is there or plowing is there, or it is a micro plowing is there, or any fracture of materials is there, or damage of the surface of the composite surface is there. The same thing what we have observed through simulations also. That is the very good things on. So you can say that again another material we developed, it is a specifically for petals only. Same applications and exactly the same what experimental is, same in through simulation also we can observe the things. So these are the different pattern of surface damages for what we have developed for wind applications only. Now the next project that is specifically for defense applications only. We'll start from here to end. It's purely on defense applications only. Whenever you have any questions, you can raise in between. It's not a problem. So here the question is that the defense vehicles, that in general it is a combat vehicles, we are saying it is a, this is a, most of the Russian vehicles are these type of vehicles. At present Ukraine war, they've used such type of vehicles only. This is a combat vehicles only, we can say that. And these vehicles, the panels, the armor panels, it is for vehicle armors, not for body armors. So it is Ministry of Textiles along with the other partner agencies, that is a TBRL is there, ARCI is there, Ordnance Factory Medak is there, NITRA is there, MNIT Uttarakhand is there, SMPP is there, and government, that is Ministry of Textiles. These are the partners of this particular project. It is going on at present. Here our target is that we need to go with a material which is lighter and more sustainable. That is the important question, is that because at present, whatever the materials are available, that is mostly all the vehicles are from Russian vehicles only. They are means specifically they are concentrated on steels only. That is the metals. There are the heavy materials. Because a simple panel, we can think about a 500 by 500. It's nearly, we can say that 140, 150 kg of materials. That is the means weight of that material. With a thickness of 10 to 15 mm, thickness is there. And our target is that to move that one, because the similar project already we did it with Ordnance Factory Medak. This is the only funding, the only agency in India who can check the ballistic applications only. That is the only agency, Government of India agency, is that they can only check whether this material is sustainable or not. So we developed initially some other material, then finally we have shifted to some other. This is a pattern where there are 3 different fibers combined together, and that is a weaving pattern only. We worked on the weaving pattern. So that this is the weaving means the target of this test of this one only. Initially, our target is development of these materials, and then we can go with this is the vehicle. You can see that that is the combat vehicle only. And here the defense person who is sitting inside, the person who is handled the vehicle, it's a periphery. So that is the more important part, is that he should save. Okay, the vehicle 100% safe, but that person is not safe zone. Okay, so there it is a armor panels. There are 4 armor panels, means front, back, left, and right. 4 armor panels are there, and that because of that armor panel, the vehicle weight is drastically increasing. So that also affects the speed of the vehicles and other things also. Even fuel also is a matter. So here target is that because Government of India is the major focus at present is the defense only. So we need to reduce the weight of the materials. So at the till 2010 we have developed the material. It is nearly 36 kg. We have reduced to 130, 140 kg to 36 kg. Now our target is it is hardly 12 to 15 kg, not more than that, by these methods only. So this is one of the technique. There are a lot of technique is that fabrication of a materials. This is one of the technique that VRTM, generally you can say it is a vacuum assisted resin transfer molding technique only. It is in-house we have developed this equipment here, and here with the help of this, because it will work in a control environment. You can send that means vacuum as well as a pressure only. That is the control environment. It's not a temperature. I will show you another equipment where it will work vacuum environment, temperature as well as pressure only. But this is only vacuum as well as a pressure environment only. And we have developed this our in-house for these ballistic applications only. So these are the weaving pattern of different fibers only. These are the different fibers we developed. This is the simulation only. We did simulation through Texan initially, the design parameter. And then we have these, and the rest fibers are these are the original weaving pattern fibers only. NITRA is the one of the agency in India who is very good for weaving of fibers only. As per our design, they can weave it the fibers because they are partner of this project only. And through simulation also we have studied that which fiber is good in which direction, because We are taking 3 different fibers in this particular applications. This is a glass, carbon, and UHMWP, that is ultra high molecular weight, that is a fiber. And these fibers are very good in defense, specifically for defense application. That is a ballistic as well as shock absorbing applications only materials. And this fiber pattern we have designed through simulations only. After that, we have performed the experimental work. So the bullet is like this only. You can see the image, that is the simulation image, that is simulated image. That is how the bullet is penetrating in the surface only. So there are different images are there. So we can understand this through this image only, that how much it will penetrate inside the body structure, because it's required that it should not penetrate first of all. First of all, it should not penetrate 100%, and there should be some deflections. Not that is maybe 3 or 2 mm deflection, not more than that. This is the boundary condition of that only. And through we can observe that which fiber will absorb more energy, because as a glass it is a slightly different. As a cheaper carbon fiber, it will absorb faster way energy, whereas UHMWP it is late because it is elastic like nature. So which fiber, that is through simulation only you can understand that which fiber will put it in which directions only. As per our weaving pattern only, carbon fiber, glass fiber, and UHMWP, 3 things we have taken. And UHMWP is a binder, we have considered as a binder only, and this X and Y direction we have selected glass and carbon fibers only. And this is the weaving pattern of these fibers, so that we can understand that because without understanding the simulated results, it's very difficult also to go with the experimental, because we should optimize first in the simulations, then you can go with the experimental, because initially we have started with the simulations only. And through the simulation results, what we have observed that these are the fibers pattern and these are the fiber directions. We should keep in, we should fix it up accordingly. So here the first, because as a good research, we need to know that the different models, like TextDen is one of the very good CAD software. It is a freely available. It is a free access. It's no need to buy or something. It's a freely available. So we can use it. This is for CAD model, and after that we can simulate it in ANSYS only. So these are the different graphs only there, and the energy probe as versus with the time, so that we can know that how much time it will take to penetrate into the body of the armor panels only. These are the energy versus time diagram of a bullet as well as the composites only. And these are the simulation behavior of the composite against the impact of the bullet. And you can see that there is only a surface slightly damaged. It's not like 100% it will penetrate into the body of this armor. So similarly, that because whenever we go for this type of reason, we should know the behavior of that the bullet materials. Generally, you can say it is FP bullets only. And here, see it here, there are different. We have started with a different combinations of fibers: glass, and carbon, UHMWP, and glass, carbon, UHMWP, like in a reverse. So different, nearly 9 different permutation and combinations we have performed. And one of this result is that is the energy versus the time only. So here the energy we observed in a weft directions, the winder direction, and wrap directions only, all the 3 directions. Accordingly, we have to plan it that which fiber will put it in which directions only. So it is a 3D weave pattern only. This is the first, we can say, weaving pattern for defense application. I don't want to say that there is no 3D weaving is available in the world. 3D weaving is available. 3D weaving people are doing for different applications, but not for the defense applications. 3D weaving for this armor, it is a totally new, you can say that. And here through it, what is the benefit for that one? That is the most is the cost benefit analysis one. So the benefit is here that we can improve the efficiency, and so because impact energy is the major factor as far as this impact means ballistic application is considered, and simultaneously we can the reduce the weight of the materials only. That is the more important, that how can you reduce the weight of the armor so that it can easily, someone can easily hold and keep it there only without crane. So if it is a 12 or 13 kg, anyone can hold it and can keep it that, because it is a holder, 4 positions holders are there. The top means left, right, and front and back. So that holder we can keep the armors only. These are how the armors are looking. We'll see that. And there are different combinations. You can see that the kinetic energy total and the individual, that is a binder, which one is better, and a wrapped internal and wrapped, that is internal energy. For all these things, energy we need to find out first. So this energy, through this energy, we can say that the XYZ fiber is good or bad. We can say accordingly. We can say that. So these are all simulated results only. This is not experimental. These are all simulated results only. See the combinations of CCC, which is a carbon, carbon, carbon only. In one direction, carbon, X, like you can say in Y direction also carbon. In the binder direction is also carbon. Like this EEE, glass fiber, glass fiber, glass fiber. UHM, WP, U. And carbon, E and U. Like this, there are 9 combinations are there. Through these 9 combinations, we have to optimize it, that which fiber we should keep it in which directions. So based upon the ranking technique, that is we have ranked through hybrid optimization technique only. That is TOPSIS one of the technique only. That is MCDM, generally you can say it is a multi-criteria decision making technique. So through this technique, we have optimized the data. That is what we have taken. We have taken the weaving pattern of the fibers. Simultaneously, their energy, that is a kinetic energy, how much absorbs, as well as the wrapped internal energy, wrapped internal energy, binder internal energy, and property of the material. That is the density of the wrapped, density of the wrapped, and density of the binder. Because the density is one of the major property as far as composite. If you think about it's best fabricated, there is a free in structure. That is there is no failure or there is no porous structures in the material. So that's because of that reason we need to consider as a density is one of the measure. There are other factors are there. We can say that it's not like density is another. Other factors are there like hardness also we can consider it. Some mechanical property also we can consider it. If you think about this particular armor, I can use it in a minus temperature, then we can take also temperature is again another factor. But as this is totally designed for Indian environment, so we have considered only up to temperature up to 60 only, not more than that only, because it not more than that is required also. So this is the environment what we have optimized on. And these combinations below the graph we can see that that is the best is the U only, that is the rank 1 only. Then carbon, 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 then other combinations are there. But if you will say that ultra high molecular weight, that is UHMWP, if I will consider in all the 3 directions, it will give better results. But it is not a cost effective because it is very costly. You can say that as compared to the carbon and glass, it is a very expensive material only. But we need to examine that how much we can compromise it. Accordingly, we have to plan it. But through simulation as well as through experimentally, I can say that UHMWP is the best. If I think about the cost is a major factor, then I have to slightly change it. That because impact is mainly it depends upon it directly depends the binding only. Binder, it has major effect is on binder only. So the binder part should be UHMWP and other 2 parts I have to manage the cost cut. So I can use it carbon as well as the glass fibers only. Because X directions maximum weaving is there, that's why it's a glass. Y is a carbon, and the Z directions, that is a binder direction, is UHMWP. But the reality is that all the three directions, if I will put it UHMWP, it will give 100% better agent as compared to all these combinations, because based upon their energy, internal as well as their kinetic energy absorption, as well as the density factor, if I consider all these three, then UHMWP is the one of the best parameter, we can say that. So here the ballistic, how we have developed that, this is one of the equipment through this is autoclave, we can say that it is a environment, is a control environment, in the sense it is a temperature, also you can manage it, because composite we are fabricating, curing is a factor, polymer, just like a metal we can go for heat treatment and other technology. Similarly for polymers, one of the basic is the curing is the important, because if it is not cured properly, there is a chances of a failure of a materials. One of the failure is that because it is a combination of a metal as well as a ceramics, so there is a chances of failure of a delamination. So to avoid that things, and proper binding is also important. That's why this is the equipment which is available in our laboratory, and through that we can high pressure, high means we can go temperature also, or nearly 200 degrees centigrade, and as well as the load also. And here load is pressure only. There is nothing like some manual load, will put it in a pressure, in a vacuum environment, will put it pressure as well as temperature only. So, and it will cure for 12 hours or means more than that also, based upon the curing of the resins only, because some resins it may take 3 hours, or some resins may take 4 hours only. Some resins it may take half an hour also. So we need generally the duration should be more, so that it can properly mix, and we can that to prepare it finally. So this is the equipment through, this is the generally you can say it is autoclave only. It is available in India. There are few CSR labs also patented this equipment also. So again the ballistics, again it is another, this is a Stenak 4569 level 4 vehicle, that is a generally you can say it is a FICV, that is a futuristic infantry combat vehicles only. And this project we did it with the Ordnance Factory Medak only. As I said that this is the only agency who can check the behavior of the materials only. So this is the Stenak, we can say that it is a standard code for 4569 level 4. There are different levels are there, level 1, level 2, level 3, level 4. Just specifically level 3 and 4 for vehicle applications, level 1 and 2 for human body applications only. So in general, we are working on level 3 and level 4 vehicles only. That how the specifically the material is, it is what we have developed here. We have developed here pure glass and composite only, along with the ceramic what we have considered is alumina only, and some other also. And this is the bullet what we have used for this Stenak applications only, and that is a 14.5 mm epi bullet, that is B32 series is only. And our ceramic is Al2O3 ceramic as well as a glass fiber epoxy composite we have considered. And the impact velocity, it is 1000 meter per second only. It is specifically this velocity works in general, that is AK-47 works only, this velocity only. And this is the panel of the ceramics, that is means the ballistic, that is 500 into 20 mm only. And here we have, this is our first project in 2015 to 2019. We worked on this only, and we have given a positive means response to or results to them only. And this is totally a weapon applications. Okay, that is means directly vehicles. That is nothing like we will go for some other test, or already it's a tested materials only. And this is the specifically for level 4 only. And the projectile weight, that is 60 grams is a projectile weight, that is, and striking velocity is 1000 meter per second only. And this is the models what we have developed initially. that is the geometrical models, that is e-glass fiber epoxy composite only. Very well we can, I mean, because through simulation we can do nearly 70 to 80% of works only. So one should be very good, very strong, specifically in simulations only, so that most of the costs, as far as cost is concerned, and time is also again another important. Through simulation, I can reduce the cost as well as time, and like also we can understand the behavior of the materials on each and everything. So there are different models are there. Okay, one, because this model is a linear equation of a state, that is here it works pressure with respect to volume, pressure with respect to temperature also. It works three things only: pressure, temperature, and volume one. And here the D is that is the damage parameters one. So the graph pattern is like this only, that if the D is like this 0 to 1, the graph is the blue line only, that is, and if D is exactly 1, the graph is the yellow line only. If D is 0, the graph is a red line only. So accordingly, we can understand that where I need to put my material. It depends. It's not necessary every time I will go with a D is 0 or D is 1, or D maybe it is a 0 to 1, but always it lies the damage pattern, the variable, that is means 0 to 1 only, always that is. So this is a linear equation of states only, and it satisfies the Hooke's laws also, because anything we have to develop, it should satisfy our basic equations. Similarly, this is a stock equation of states also. Here also we can once it will strike the surface of the ballistic material, how much it will absorb the shock energy, that is. So that's why to use what we have used, it is the shock equations of states only. Through that we can understand the how much it entered into the armor panel, and let it strikes and revert back only, and some other directions. That things to know, that is this specific equation, so we can use it. And similarly, because these equations are all materials models only, because in simulation measure is the material models and the failure model, two things. This is a materials models only. There are different material models. One can find out the material model through linear equation of state or shock equations of states. Again, the materials model only, but we need to find out the strength also, because that will find out the previous two equations, like equation of state and shock equations. That will find out the damage materials, damage behavior of the materials only. Damage is one of the parameter. And this one, these two equations, that is Johnson-Solomik 2 as well as Johnson-Cook model, both two, they are strength parameters. Like whenever we go for a tensile strength, we need to know that the materials, how much the tensile strength or flexural or bending strength or interlaminar shear strength or impact strength, these things. Similarly, for ballistic applications, these are the strength models are there. Through that, it is no doubt it is an empirical model, but nearly you can say that if your model is perfect, CAD design is a perfect, nearly 95 to 100, nearly 99.99% accuracy will get it, if the materials model is perfect. Otherwise, because there are different way to model the materials only. If the metal model is perfect, then it is easy to understand the behavior of a materials only. Otherwise, it will fail 100%, because if the CAD model has some defects, or the proper boundary condition is not there, or the nodes and elements arrangement is not proper, because it totally depends upon the multiple, because black box it is, ANSYS is a black box. It could not understand anything only. The way we will arrange, it can understand the things only. So that's the important, the CAD design. If it is a perfect CAD design, then accurate means strength we can calculate it for different materials only. This is same only for different materials, and for as far as design is damage is considered, that is D 0, the graph pattern is like this, and the D is 1 point, that is a fracture totally, and if it lies between 0 to 1, then you can say it is a damaged one. Okay, these are the three things. So in a strength, how we'll calculate it? If it is either it is red line, it is a fracture, or it is a damage, slightly it lies between 0 to 1, maybe 0.7, 0.3, 0.5, or it is D0, then you can say it is a intact only. Okay, these are the three things only we can find out through this materials models one. So similarly, failure model is there, because once you know the damage of material, then you can say that through failure models, it is a advanced Johnson-Salmick model. That is, through that we can find out the failure of the materials. So it is a graph between the pressure as well as the fracture strains only, and the tendency of the damage, that is how it is, that we should know it, that the behavior is just like a projectile, or it is a 45-degree angle or 30 angle is there. So it depends upon that only. So we can find out it's a totally based upon the plastic strains only. That is the strain energy principle. We can calculate it. This is the failure models of different materials. Similarly, failure models of, because not necessary I can go with some one. So that is a Johnson-Cook failure model. So here, see it here, because this type of a graph already we learned through material science, that is a material is a brittle or a material is a ductile. So the graph is like this only. It is a Johnson-Cook failure model. If it is up to A, then it is a damage initiation is there, then damage evolutions, and finally it fails. That is the failure, complete failure is there. That is through that strain versus stress curve only. So we can find out that how our behavior of a materials only. So through that we can say that because this graph can explain you that what further modification is required in that material. That is the more important, that how can you modify that material. So if it is will reach damage initiation and there is no further growth, it's okay. Then damage evolution is there, then complete failure is there, then we need to rethink about that. How can we change the materials or the behavior of the things or the applications of the materials, these things. So these are the results only. These are the simulation as well as the top one, the experimental results. Below one, the simulations only. That is exactly, it is penetrate like this. In reality, the patent is that the bullet will penetrate like this only. It is looking like this one only. It's just half maximum. We can say that 100 microsecond it took, means it will take time. That is the target after 100 microsecond, means so minimum. It can say that 100 microsecond it will take to penetrate into these structures only. So these are the different, because one of is 100, another is 120 micron. So accordingly, we will find out that because the velocity we have started from 1000 meter per second, and how much time it will take to penetrate into the body structure if you will come with this much velocity. That is a 1000 meter per second velocity. So means gradually it will enter into the body structure. So 100% when it reach 100, so complete it entered into the structure of the target materials. So these are the means tested results. We can say that these are all the tested results only. The top one, top left, this is the panel what we have developed. Top three, all these three we have developed in our laboratory, and that we have tested in a ordnance factory Medak only. And see, this means whole means multiple time they strike the surface of this ballistic. Only upper surface, like because upper surface is resin as well as one layer of fiber is there, that only damaged, and the rest everything, because one red is there, that is the damage, means 100% it entered into the body. Okay, and the rest, the green tick is there, that is there is no failure in that material. Only multiple times they have strike on the surface of this target materials only. Here main is that whenever anyone will go on work of this particular type of materials or this particular type of applications, one should know that the density of that. Here is the density, is the aerial density. So we need to find out the aerial density, because the ballistic applications only depend upon the aerial density only, no other density. We have to find out the aerial density. If based upon the aerial density, I can say which is lighter, which is means heavier one. That is. So their calculation is only in terms of aerial density only. See the green panel, aerial density is 128.1 kg per meter square, and the yellow panel it is 129.9. So these two panels are there, and the aerial density. So nearly same. Both are aerial density is same nearly, but the materials are different. One is green panel and another is the yellow panels only. The materials are slightly different, but the aerial density is nearly close, you can say. So this is again through this test, that is we have developed a panel that is a B4C, that is boron carbide and Kevlar fibers. See that because I am not feeling well also. So the density here, what we have calculated, the density, the flexural strength, and the hardness of the material, elastic modulus, and the microstructures of these three things what we have calculated. And we observed that the total boron was, it is a composition, it is 81% is there, and iron is 0.5% is there, and rest is total boron and carbon content only. And these are the materials what we have taken, because already these are published things. That's why we are showing these results. So here the matrix material what we have taken, it is a epoxy materials, and it's a basic materials only. But don't think the epoxy is the same in. There are multiple series of epoxies there. So we need to find out specifically which epoxy is good for this one. And the ceramic material what we have considered is a boron carbide, and the size of the panel it is a 500 by 500, and the aerial density is 74. See the previous one, aerial density is 128. Now the aerial density is 74.5. Further, our target is to reduce that aerial density. So these are the different experimental. The right hand side both are experimental results, and the left hand side these are the simulated results only. So I can say that because we need to validate somewhere that your experimental results, because no need to validate, only the simulated results I have to validate it. So we have validated that it is exactly same what we have predicted through simulations only. And these are the results of real experimental results only. So there are other applications. Once we can develop a material for a ballistic, I can use it some other applications also, like at present. Why I said it is a initial solutions for sustainable ballistic or the defense material. Reason is that at present, Government of India is working in these 4 areas only at present. Specifically the development of material. There are thousands areas, but as far as armor is concerned, as a helmet, because this is again another important part is there. It can sustain -65 temperature to +60 temperature. So helmet, development of helmet, and then body armor, that is specifically people are working on body armors. And this is a ballistic panel what we have developed, ballistic application, and last is the military vehicles. So these are the 4 areas open. Anyone can work on this area. And we are there to support if any required helps, all these things. But these are the 4 means as far as the development of material is concerned. If anybody is working on this, then they can develop it. That material can apply for project and can get the funds from the different funding agencies, not necessarily textile, or it may be DRDO, it may be ISRO, it may be NRB, or it may be ISRO also, or it may be BARC also. All are working on this. There are different aspects. So this is again another project with the industry. One of the industry, we are working on this project only. That is it is a level 3 vehicles only. As I said, it is a level 3 vehicles. That is a NIJ level 3. So these are the conditions, test range. One should know the test range of that one. It is available. This document is available in the open market also. It is available, this document. So we should know it that if it is a type 3 armor, Then the test cartridge, that is the test material, it is 7.62 into 51 that is the code is there, rifle, and that is the bullet weight, it is a 9.4 to 9.6 is there, and reference velocity is nearly it is a 850, that is 847 plus or minus 9 is there. And the shot per panel, one should know it, that is a very interesting, minimum 6 shot is required, minimum 6 shot. Without 6 shot, this material testing is not valid. So we should know the code also, that is NIJ level 3 code. Let's say NIJ level 4, it is a 1000 velocity meter per second required. NIJ level 3, it is 850, nearly 850 meter per second is required, the velocity. And the shot must be minimum 6 shot is required. And here the bullet, the whatever using, it is AK-47 or it is a 56 rifles, two things they are using. And these are the other parameters are also there, that is a protect, because the available guns as Russia or it is a Chinese only, the guns available. So in general, India government, most of the guns are Russians only. And you can't believe it, at present, government of India is developing, so means Make in India through it, multiple guns and bullets they are developing now. So like how we are developing panels, there are other groups are also there, they are developing panels for different levels. What is the what we are developing? It's a level 3 as well as the level 4 only. See this, and this is the the testing conditions are there. How we will test it, and these are the available literatures also. All these things are there. From gun barrel to the target, what should be the distance is that, and how it will means the bullet will go through this path, this and how can we capture the image of this. So these are the this complete setup is there, so that we can understand, we can see the things also, from bullet to, that is the test barrel, to the target armor panel. See this one, it's a maximum, we can say that it's generally it is a measures from the center to center only. So here you can say maximum it is as you see the results only, the rifle rounds, that is 15 meter only, and the handgun rounds generally 5 meters also. That is a different criteria is there. Accordingly, they can strike the target of the armor panels only. So this is the level 4. For level 4 also we should know it, that what is the minimum conditions are there, and same as level 3 only, but it slightly the velocity is 870 to 1000, means 880, 90 like this. So 1000 generally fixing. Why it is 1000? They will fix it 1000, but when it go through projectile, the velocity, target velocity, when it will strike the target of the armor, it's reduced because of the as it passes through a open environment. That's why that time the velocity is nearly 900 meter per second. So that's why reference velocity we are saying it is a 878 plus or minus 9.1 only. And there are different ballistic tests is that, non-standard test and standard application assessment is that. There are different levels are there, type of protection is there, type of threats is there. So type of levels like says international is there, regional is there, national, military organization, there are different levels. So everybody has divided up their own. And type of protections like a human, or it is a technical, or it is a building body. Like similarly, type of threats, it may be bullets or projectiles and bombs like this. So we are working on the armor panel as well as a bomb. Today I means the slide I forget to include it. That is about the bomb part. It is we are working on this one only, and that the result was not declared at till date. That's why I was I felt that it is not necessary to go with this one only, and otherwise we are working on this also. So there are different testing of materials, and there are different equipments, so that we can understand. So it's not that easy. What you can say that the test, whatever tensile test we are doing, it is not like this same that is. So here the tensile test is a HNS, this is a plate we are doing, and it is a this test is available in our laboratory, in institute, we can say that. And these are the tests we can read. And the V notch impact test is that is a Tinus ones. That is a V notch impact test is there, because we have to study all these things experimentally. Then you can say that these results are when it is a high nitrogen steels only. This is applications what we are working with the Jindal. It is a high nitrogen steel only. This is it is a means one of the test, so that we can understand the quasi-static, that is a compression test only, and another is a SHPP test. It is that is a this is a like tensile, but it is a means a very slow range that we can find out, and simultaneously the frequency level also we are maintaining how much it is. That is in general, such equipments are very costly equipments. This is not available. It's available in other part of this country. That is generally you can say it is SHPB, that is a split Hawkinson's pressure bar test. And most of the laboratories available. We don't have this equipment. We have to test through that only, so that we can find out exactly, because it is a high strain test only. In tensile test, whenever we go, it's not under this category only. Room temperature, high strain rate, compression test only. This is through this we can find out also the compressive strength of, because it's a tensile is there, compressive is there. So this is a compressive test is there. That is a split Hawkinson pressure bar. We can understand the means the test conditions. That is how much the strain rate. We need to find out the strain rate, so that based upon the strain rate, we can simulate the results only. So these are our results, our equipments available in our laboratory, and that is the different equipment. That is FESEM is there, and optical microscope. TEM is there. That is FESEM, and TEM is that transmission electron microscope, as well as XRD. All these tests are there, and this is the autoclave only, how we are controlling. And these are the body panels of the different what we have developed, different body panels. So now see the results only, how people are working, and as this material was developed by one of the renowned industry in India, that is JSL, that is Jindal stainless steel, that is high nitrogen steel, and specifically they are using some other applications, but they are also using for this ballistic applications also. So this materials we have taken from there, because we are working with that only, with Jindal only. So these are the results only. These are the Jindal, the CAD designs of this. And here we can understand that it can sustain maximum, that is 762 meter per second, up to that only. Our target is it should benchmark with the level 3 and level 4. So we changed it. Initially it was penetrated, and completely it is entered and come out also, because it 100% it penetrated into the body structure of this high nitrogen steels only. There is no composite is there, only the steel material we have strike first, so that steel material only will put inside the composite only. So these are the things. So like this, there are different boundary conditions we have studied, and we came to know that, see this image, it's not 100%. It means it's just come out. So slightly we have modified, and the property of the materials, and even the thickness also, because thickness plays a major role. Thickness also we have considered as far as our experimental condition is concerned. See there again, like because in all the cases, only there are few parameters we have changed and a few parameters we have fixed, so that the different options will go it, and then you will come to know at the end. See this one also, how it is like this. See completely, so just to change the thickness slightly, and it completely fails only. So based upon that, we prepared different combinations. That how can you prepare it? These are experimental conditions only. based upon the aerial densities, how we have prepared. Just you see first row, that is a glass fiber, ceramic, glass fiber, steel, glass fiber, like this a combination. So there are different combinations we have prepared, and the thickness, it lies from 9 to 12 thickness is there, and the aerial density, because aerial density plays a major role. See that based upon these combinations, the aerial density changes from 31 kg per meter square to 53.8 kg per meter square. How the aerial density changing? Only by changing the fibers only. Rest ceramic and steels are there, but once you change the fibers, that is the Kevlar fiber we have taken, and same we have taken carbon also, same we have taken UHMWP also. But by changing the fibers, the weight changed, and but we have to compromise somewhere that where to stop that one. So this is the different combinations we would prepared it, and the result one by one results we have started. That is the 7.62 bullet. It is because it is a standard 3 level 3 applications, and the panel of the thickness, that is 10 only. It is a thickness, and a glass fiber and high nitrogen steel HNS, then glass fiber, then boron carbide, and then glass fiber. Like these combinations we have arranged. Okay, accordingly we will start the simulations only, because these combinations also through literature as well as some experience, past experience, because we have used already boron carbide, and we have used glass fiber, and we have used other fibers also, but we never tested a high nitrogen steel. So we thought we should keep it high nitrogen steel at the top and boron is the bottom. Reason is that if steel fails, then 100% boron is there, ceramic is there, it can protect it. So based upon that plan, we kept the base is the boron carbide, and the front we have kept it is a high nitrogen steel only. And otherwise, what you can say, I will take only high nitrogen steel 10 thickness. That weight will cross more than 100 kg. It will cross more than 100 kg, depending upon the armor sizes, 500 or 500. If you think it, more than 100 kg, but it will hardly come 18 kg only. Because here the thickness is the plane, means how we can manage the thickness simultaneously, we can reduce the cost, and along with we can reduce the weight of the material. Mostly the weight of the materials. That is the important, that how can you reduce the weight of the material. More important part is that. See that the structures, how it is, the results are there, and how the damage pattern is there. That is a glass, steel, glass, carbon, glass, like this only. This is the pattern only. And the velocity, impact velocity, or we can say it is a muzzle velocity only. It is a 930 meter per second velocity. It is through simulation only, you can say that. And so through different combinations, then we changed it, because in a 9 it is the damage is slightly different. Then we have gone to the 10 thickness, and here it is again same condition. Muzzle velocity is same 930 meter per second only, and the same combinations are there. Only slightly we have changed the thickness, and we have observed that how much the damages are there. See this one only again. We have taken Kevlar, steel, glass, carbon, glass, like this combination, 9 thickness. Totally how the damage pattern is there. Totally it is damaged. So, but simultaneously its aerial density is also high. This is the pattern of that penetration depth of it. And again we have taken is a 10 thickness is there. Again same conditions, same with the 930 meter per second the muzzle velocity is only. And it is how it, the top one totally it come out, and the bottom one slightly survived, slightly, but it is a penetrated. So like this different combinations. See these combinations. How can that, through that only I can say that at the end we can say that without simulation, nothing. It means these studies are particularly whenever you go for high-end applications, simulation is a mandatory one. And we are hardcore experimental, but we are doing simulations only, because through simulations I can optimize the whole process. So that is the important data. See, this is 11 just 1 thickness we have changed, and the velocity is 850. This velocity is there, and 1 mm. Then we have again increased it to again another 1 mm. That is 12 mm thickness is that. And see the damage. Before one, how the failure is a 9 and 10 mm. Only 1 mm thickness affects how much. And simultaneously the combination of that. Combination is important. Back one, the combination is Kevlar, steel, glass, carbon, glass. And here it is a glass, carbon, glass, steel. Like this carbon is here. Either we are putting the ceramic or we are putting the fiber and ceramic. Combination is there. So we have taken here only the ceramic only. We kept glass top, impact side, glass top, then ceramic, then glass, then we can say steel, and at the end is the glass only. So the ceramic and the carbon is a combination in that. Either you go with ceramic with carbon or else you can go with the ceramics only. Only thickness is the defect. Means how much the thickness we have to manage it. So with that thickness, see it here, only 11 mm and it is protected. It damage on the surfaces only it will damage, but it will never, it will penetrate. Only the below one, the deformation is important because up to certain deformation it is allowed. As per the guidelines only, that is STENA guidelines is there. As per the guidelines, up to we can say that for vehicles up to 2 mm thickness is no problem. For human body, it's a 0.5 or 1 mm thickness is deformation is okay. Otherwise what? If it will deform more, then it will automatically it will penetrate, means it will strike the surface. No doubt if the bullet will not penetrate, but there is a surface pain is there. So that also we need to work also. That how can you reduce the, let it will not penetrate, it's okay, but there should not be a maximum deformation. It's through simulation pattern, it's like this only, but it's a hard mixture. You can say 1 or 2 mm is the deformations only for vehicles. There is no problem at all if it will deform 1 or 2 mm thickness without penetrating. See here again another combination is that is a Kevlar, carbon, glass, steel and glass, and this through this is again another combination is there, 10 mm thickness, like this only. And at the end we have compared that as we worked on Al2O3 and aluminum nitrate both, and this paper is already available in International Journal of Impact Engineering, this is purely like this only. This is the finite element analysis and experimentally both we did it. That is 7.62 Fe. That is the armor panel. Bullet on ceramic as well as aluminum bilayer hybrid were carried out using autodyne. We have used ANSYS. These are ANSYS part of that. ANSYS LS Dyna, ANSYS Autodyna. So ANSYS another part is that is ANSYS Autodyne. It is also very good software. It's ANSYS Autodyne. It is very flexible also to use it, this particular. So what we have studied initially, we have prepared the ceramics. Just you see the center point is the ceramic, then periphery, the composite. It's a slightly different design. Periphery we have prepared composite so that someone should hold that ceramic. So we design in such a way that the ceramic, because I can't go with a 500 by 500 mm ceramic only, because it is not necessary also, because the bullet will strike always. It's not a corner of anyone. It will always strike the center of. So that part I need to protect it, and that is the part the ceramics only, and the rest is the composites only. And the bullet is accordingly. This is the design only. And this paper is already published in the International Journal. And some geometries and finite element conditions are there. These are 8 nodes brick finite element, that is for projectile geometry, and target bodies of about 1920 to 1,23,472 respectively. These are node and elements only. And our target here to minimize the time required for computations analysis to make the particular model, and the output parameters that we have considered or we have taken, that is projectile velocity, depth of penetration, and back phase, and radial deformations. That is the deformation. That deformation generally we are saying it is a radial deformations we have measured. See, this one is the simulated results only. These are all simulated, and I will show you the experimentals also. These are all simulated results. So here means what we have faced, because when we have published this work, when we have started this work, nearly you can say that 2013-14 we have started this work, and lot of permutation and combinations we did it, because always the back face deformation of this, you can see it here also, the blue line, that is back face deformations. That is very important, that because if a bullet will penetrate up to certain extent, it's okay, but the deformation should not be measured, because initially we observed that no doubt bullet is not penetrating into the body, but the ballistic material is deformed, means it is nearly 6 mm or 8 mm like. So it is very dangerous in nature. So it should not cross more than 2 mm thickness only. More than 2 mm the deformations. So we worked on this nearly to more than 1 year. We worked on this. Then we finally concluded that what exactly required in the design only, because everything is same. The fiber is same, the composite is same, the ceramic is same only. Only the arrange means how we have arranged, and how many set of laminate, as it is a laminated structures only. How many laminar means the layer structure should be in a back plate, how many layer structure should be in the front. So that combination, it took only 1 year to understand the things only. So these are the different boundary conditions of what we have observed, that that is the curved surface of a metallic back plate is constructed to move in any directions using the fixed support only. And we have tested in the 480, means 840 meters per second. So these are the things only. And we have taken the aluminum 5083, that is the back plate we have taken it is. And these are and different other boundary conditions are there. See again, same material models, what I have shown you. Every time if you go develop something in simulation, so we need to study its a property, it's a physical property, it's a mechanical property, it's a failure property, that is more important, as well as it's a material property. So material property is very important, so that we can compromise the type of material, which type of material we can put it in the applications. That's why material property is one of the most important parameters is there. And this is the, through experimentally we can say that Al2O3 and aluminum nitride and equations, what equations, we should know it, which equations we will use it. If it is a metal, it is a polynomial type of equations we have used it. And the strength and the failure, both we've used it Johnson's Cook model, something Amar Cook model. And if it is a steel, that is a 4340 steel we have considered. And here the equation is linear equations. All these things through literatures only. It is not that easy to understand that tomorrow I can take XYZ material and I can use it any equation. It's not like it. If it is a metal, this is polynomial equation. If it is polyurethane resin, then it is a shock equation. If it is a steel 4340, then it is a linear equation. If it is aluminum 5083, then it is again linear equations. And equation of state. To understand the damage, that is equation of states only. To understand the strength, that is Johnson's models only. So Johnson Cook model is for this steel as well as aluminum. And for failure, we can say that Johnson Cook as well as hydro. Another model. These are all theoretical as well as empirical models. It is a theoretical models and simultaneously we can say it is empirical models also, and gives accurate result. As I said, if our model is perfect, the CAD design is perfect, node and element arrangement is perfect, then 100% will get accurate result. That is the more important is the case. So this is the different equations what you have studied. Whenever it required, you can contact it. That because we are working last 10 years, nearly last 10 years, and we have crossed all the milestones, whatever is required, the milestones as far as the guidelines of this STEDAC. So you can say that this is the because we should know it fast. This which equation you'll use it for a strength purpose, what equation you use it for failure purpose, what equation you will use it, and how to use that one. These things we should know it fast. So these are the results only, and these are all successful results only, and these are published also, as I said that. And these are the multiple Al2O3 as well as aluminum nitride. Both the combinations we have taken it, and only we observe that which will take maximum time. Means at a 0 micron, what is the position of bullet? At 10 micron, what is the position of bullet? At a 20 micron, what is the position of bullet? At a 30 micron, what is position? 40 micron and 50 micron. That's khatam. That is the main. So we should know also the really how much time it will take to penetrate into, because it will penetrate gradually. It's not like we will strike and then it will go. As we are saying, it is the material is sustainable. Definitely it will take some time to penetrate. So that penetration depth and the time, that is more important as far as the ballistic application is that how much time it will take. So it's the maximum, that is 50 microsecond it took. Whereas if I will go with the aluminum nitride, 30 microsecond only. After that it stops, means the bullet fails. As far as Al2O3, it required 50 microsecond, and whereas aluminum nitride, it required only 30 microseconds, and same we performed in experimentally also. So these are the damage counters of the armors for 100 microseconds, aluminum Al2O3 and aluminum 5083 and aluminum nitride. This is a combination of armor panels. Nobody will go with a single or virgin materials only. So always we need to go with some combinations so that we can reduce the cost and improve the performance. That is the more important is that. So how this patent is there, and these are the different results are there, and these are the real experimental results. See the experimental results. The figure 1, that is the ductile hole, that is engagement with the material accumulation that is caused by the impact of that is 7.62 epi bullet is there. Then you can see that the figure 2, that is that it is the small hole. You can see that red zone. You can see that also how much it is, and all sustained. Nothing failed. It's a real bullet, real study, and real material we developed, and the target of Al2O3 and aluminum 5083 is also good, and aluminum nitride and aluminum 5083 is also good, but aluminum nitride is far better than we can say that the other ceramics, and along with the base material, that is aluminum 5083. Aluminum 5083 is the base materials only. And composite, what we have kept upper, that is just to hold that materials, okay, hold that the target armor. So because of that, otherwise this polymer has no role as far as this particular. Because initially we have started with ceramics, then we have moved to composite, and now the composite is composite with ceramic, and then now we are shifted to slightly towards metal, because a lot of steel industries are there in India. So their argument is that why we will go with the ceramics only, because ceramic is we are not developing our own. So in general we are purchasing. So as a lot of steel industries are there, why not we go with the steels only? So what we have said that we have compromised with the ceramic and steel, and half of the ceramic and half of the steels only, so that it can survive. We can use both these materials. So this is the 10 image of the impact where the position impact. That is the 10 images that is the transmission electron microscope is there before and after impact, showing dislocation and strain counters in grain after the impacts only. And hopefully this is the part what we have did it, and there are some results also there, some energy versus time, and means through this I can say that my kinetic energy for Al23 how much and aluminum nitride is how much, my bake phase deformation with respect to time, my projectile velocity with respect to time, my depth of penetration with respect to time. All these things we have calculated experimentally. All these things. These are all experimental results only we have calculated, and this is a comparison between the two materials, that is Al2O3 and aluminum nitride. This is our beginning we have started, and I have shown at the end this one. And this is the laboratory where I am sitting here at present, and here most of these equipments we have, and we have developed a lot of materials, and these are our laboratories are there. And any questions from audience sides, you are most welcome to ask. As per the timeline I have completed. Any questions, you are most welcome to ask.
Thank
No
you,
doubt,
sir.
this work is totally our research only. So why I have shown this, otherwise I can show something else. Because I am interested that people should work on defense. Only because of that reason I have shown these things. Otherwise, there are a lot of results I have to hide it also. मैं बहुत कुछ छुपाया हूँ और कुछ बताया हूँ. It's difficult also to say each and everything. So it is now is open. You can ask any questions, which is possible from my side that I will answer it, and otherwise no, I can say no.
Good evening, sir.
Good evening, sir.
Yes. Please.
Sir, my doubt is regarding this ballistic application. We have chosen different fibers like glass fiber, carbon fiber, and in the case of helmet and body armor, we have chosen Kevlar fiber. And when it came to the other application, we choose. Can we choose Kevlar for all the applications, or is there any limit?
See it here. That is research. Because I'm not a god also, I can say that you can take it Kevlar and use it each and everywhere. It's not like. I am saying that these fibers are the ballistic application fibers, which is carbon, Kevlar, UHMWP, as well as glass fiber also. These are all ballistic applications. So ballistic means what? It may be the body armor, it may be helmet, it may be vehicle armor. It's not like. So I can say that even you can't believe it. People nowadays are using natural fiber. You can't believe it. I have applied also one of the project in natural fiber to one of the funding agency. If I will get that, I will inform you that even natural fiber. See it here. If it will success, no, then you can say it is a dream to government also. Because natural fiber is available in our country. It's not, we no need to go with or depend to some other country. If it is a natural fiber, no need to go with some other country. So that's why I planned that because a lot of natural fiber work we did it. That's why we thought why not go with natural fiber, some combination. So we thought that we will put it natural fiber and some other fibers also. So it is open. So now the question is that if you are strong in simulation, if not, try it. Do it, start that. If not, you start working on simulation. So you will get your results. You no need to depend on others. No literature, nothing is that. If you are strong in literature and as well as simulations, all the results you will get it through simulations only. After that, you can go for experimental. So as far as my experience, you can say that we worked on more than 22 projects. That only whenever you will apply project to any funding agency, they will see your potential. Initially, they will see your potential. How they will see your potential, that is, you have to say it. In simulation, I have completed this much of work, and rest experimental I will do once I will get the funding. So then only 100% there is a chances of getting a project. Otherwise, at present day, getting 30 lakhs, 40 lakhs also tough. We are working on nearly 4 crores, 5 crores like projects only. So it's even in helmet also, you can go with a Kevlar as well as some other materials. It's not like, but you have to study. See, helmet is not like someone will strike the bullet, it will not penetrate. Now, if that helmet you will prepare, nobody will take that one. Present day helmet is what? In Siachen, I hope most of them listen about that things or heard about the things that most of the time our army, they died there only. Only one reason is that they are unable to understand when the ice will come, the iceberg will come, and they will dig in deep inside it. So people are now trying developing such type of helmets so that it can sense that there is means ice is coming, rain is coming. So that sensor also we can put it. We are working on that also. But if you develop it, हमें तो सब कुछ नहीं कर सकते हैं ना. We can't do it each and everything. But we are trying. So if someone will work on helmet, no, go with that design. You can understand it should not penetrate. That is the first. And second thing is that it can sense also the opposite. Maybe a person is coming who will fire to you, or a ice is coming. It should sense something, so that the army officer, the army people will allot accordingly. And they have a jacket also. If they will knew about, उनको पता चल रहा है तो they can open the jacket and they can survive. But 99% they are unable to knew about the things that if something will happen. That is the problem. So if you put some sensor on the helmet, and then it is a very good project only. You will get 100% good amount of work. I hope you understand. हमारा काम थोड़ा ज़्यादा बोलने का, तो हम बोल दिए तो फिर. But if you are satisfied this one, it's good. Otherwise, you can ask again.
Okay, sir. Also, another doubt is in another case we have given different layers like the glass fiber, steel, then again ceramic layer, then again glass fiber layer. How these different layers are bonded together? How will you bond these layers together?
That is the equipment. That is the play of the equipment only here. As I shown that that is the autoclave, no? As I said that it will high pressure, temperature, as well as the vacuum environment. So if the three conditions are there and resin is properly intact, and then it can bind it 100%. As I shown, हम तो सारे each and every bullets the impact testing I have shown, nowhere there is a delamination is there. It is only the game plan is that you have to fabricate it by some technique. That is what we have used is UHMWP. That is VRTM technique, vacuum assisted resin transfer technique model and modeling. And that once we'll prepare that one, then that we will put it inside the equipment, that is autoclave. There it will cure it for 24 hours, 12 to 24 hours, depending upon the type of resin's density. And because it is a high pressure with the temperature as well as the environment, automatically it will bind properly. No chance it fails.
Are we taking this steel in fiber form or in the form of sheet? The steel?
No. Room temperature only steel. There is no thing. Steel fiber, steel mat. We have not taken any mat steel. We have taken steel only in solid. And fiber is a glass or carbon or Kevlar like this. Okay.
Plate, like plate form.
Like plate form.
Okay, sir. Thank you. Thank you very much, sir. It was a nice session. Thank you.
Very good. Very good.
Good evening, Professor. This is
Yes.
This is Lakshman Kumar, SM.
Yes.
I have one doubt. We are also working in the armor jackets.
Okay.
But while you are using the metallic plates in the sandwich panel, means sandwich plates, are you facing any debonding nature between the fiber and steel plate?
There 100% it is, but you have
Yes.
to use it some binder in between. Okay, that I can't say right now, but you can find out literature. Okay, you can put it some because the resin is there, no doubt, and simultaneously only the resin will not intake. Okay, no. So some type of means another type of a gum. You can say that you can put it in between, so it will bind it 100%. It will bind it.
Okay.
You have to make the surface slightly rough, the steel, slightly, not 100%, just to rough, so that the resin can properly bind it.
Okay. Okay. Thank you, Professor. I have one more doubt. Is it possible to create any structures for diverting the penetration of the bullet inside the plate?
Diverting the penetration, see it here. Diverting the penetration is not your goal. It will penetrate 100%. It will strike means someone will come and strike means it will deflate, it will penetrate. Diverting the penetrate is that is a technique, as you say that. Like in Israel have that is the umbrella, the dome. I hope you knew about that dome. It should not penetrate into the structure. It is through satellite only. But that is not our concern. Our concern is that the bullet should strike and it should not penetrate. Okay. Someone will come and strike, he should strike, no problem. But it should not penetrate into our armor. And about diverting the bullet, it is a different technology. Through signals only we can change it. But if that we will do it, then we no need to go for study of this armor.
Oh, thank you, Professor.
Okay.
Any other questions, participants? Okay, now please, I request you to switch on the videos for a photo session. All the participants are requested to switch on the videos.
Okay, so participants, you can switch off your videos. Sir, it was really a very impressive and informative session, sir. We are really thankful and obliged that within a short notice period, you agreed to prepone your session for today. Thank you so much, sir. We will be beneficial if you share your PPT for the participants.
No problem. I will definitely share this. Because whatever the things I have shown, these are all published work. There is no problem at all. I will show you. And I am sitting always here only, so it's not preponed or postponed. So up to 9 means 11:30, I am here only. Otherwise, it is not possible to work because we are involved lot of other official works also.
Yes,
so okay, it's a pleasure for me also to get opportunity to say something my state peoples and the others also there. Okay, nice to meet you and thanks.
Thank you, sir. Thank you so much.
Sir, if you want to contact means how we can reach you, sir?
The world is very small. World is very small. So you can contact me through mail. Okay, my mail ID is there, and if you want my mobile number also, then both the madams have hopefully. So you can take that also number. So
Okay.
we are always ready with that also, no problem at all. Okay.
Okay. Thank you, sir. Thank you.
Sure. Thank you to all. Namaste.
Thank you, sir.
Thank you, sir.
Namaste.
Namaste, sir.
Thank you, sir. Thank you.
So now the session we can end it. So tomorrow we will meet at 6 p.m. Hello.
Hello,
Yes.
ma'am.
Amrendra, sir. Yes, sir.
Ma'am, in attendance in Atal Fdp registration, I do not find any attendance, ma'am. Actually, I
No,
missed that.
No, we are not giving any attendance for this, sir. Automatically, the attendance is recorded. So
Ma'am,
you
already
just
I have applied that FTP from yesterday onwards. And kindly please add me in the WhatsApp group so I can find out the PPTs, ma'am.
okay, sir. You can pin me in my WhatsApp. I will
Yes,
add
ma'am.
you. And
Ma'am, already I have sent 2 times
okay, sir.
the messages.
Okay,
and
sir. I will
WhatsApp
check.
number.
But you just join with your registered email ID, sir, so that it will be
Yes,
better
ma'am. Yes,
to
ma'am.
have the
I have
attendance.
created. Ma'am,
Automatically,
I
it
have
will be
created.
recorded.
Ma'am, I have already created a mistake in first day, but on 2 days from yesterday onwards, I have joined
Okay,
in that registered mail ID.
okay, sir. Okay, no problem, sir. So
Okay,
now
ma'am,
we are
please add
closing
me
the
that
session.
in that WhatsApp.
Okay,
Thank
sir.
you.
We'll take care of that. Okay. So and the participant just fill up your feedback form. We are sharing in the WhatsApp group. So for today's feedback, you can submit it by 11 p.m. 11 a.m. by tomorrow. Okay. We are closing the session. Thank you. Thank you all.
Thank you, ma'am. Thank you.
Thank you, ma'am.
Thank you, sir.